Hello, my name is Dave Martin, and today I'll be speaking on the subject of digital engineering, CAD administration perspectives from the worlds of drones, rockets, and consumer electronics. And our agenda for today, I'm going to first talk about the need for innovation in CAD and PLM, then how CADmins need to change, how training needs to change, transforming computer-aided design to computer-aided engineering, and transforming CAD and PLM from support to strategic, and then discuss some next steps. And for over the past 6 years, I've been a CAD administrator or CADmin and a designer at Amazon's Lab 126, Amazon Prime Air, and Blue Origin. First, thank you for being here. So Amazon and Blue Origin have created both innovative products and new markets in recent years. Many of these are very famous and have become part of the cultural zeitgeist. We're so used to them that we can forget they haven't been around for that long. For example, the Kindle Reader has been around for less than a dozen years, and the Amazon Echo smart speaker with Alexa for 5. The first Prime Air drone delivery was less than 3 years ago, and some of you may have seen the unveiling of the new drone last month. New Shepard was the first rocket to have a successful return landing less than 4 years ago and was reused on its second flight only 3.5 years ago. And for clarification of all the milestones I've just listed, I was only around for the Echo and the Prime Air first delivery. And the drone, let me show you the drone on here that you can see on this slide. That was the one from the commercial with Top Gear's Jeremy Clarkson, and it sat on the table behind my desk for weeks as we worked on it. I've learned that if you want to create revolutionary products that create new markets, you can't do it by operating in a business as usual fashion. The way you think and the approaches that you take have to be innovative as well. Here's the core point of my talk today. In order to build innovative products and new markets, we need to serve our external and internal customers with equally innovative approaches to CAD and PLM in 4 different areas. First, CADmins need to change. Second, the way we implement training needs to change for the 21st century engineer. Third, we have to transform computer-aided design to computer-aided engineering. And finally, CAD and PLM need to transform from support to strategic roles. Before we go into this, let's talk about the stakes. What's the risk? What if you don't do any of these things? What if you don't innovate or seek to create innovative products or seek to create new markets? Can't you simply cruise on what you already make and do? If you don't innovate, you put yourself at risk of getting disrupted. Ask these companies. As Peter Drucker says, innovate or die. And people can get disrupted too. If you're an engineer and you avoid new processes and technologies like model-based definition, additive manufacturing, topology optimization, generative design, augmented reality, and Internet of Things, you're putting yourself at risk. I started my career as a structural analyst at Martin Marietta. Back then, there were designers who never learned CAD and still worked on drafting boards with protractors, French curves, and electric erasers. Other analysts I worked with never learned FEA and did all calculations by hand, which is an amazing skill. During the economic downturn of the 1990s, though, they were the first to be laid off. Let's be honest, they were fired. They failed to evolve. If you don't innovate as either a product development organization or as a person, someone else will, and they'll eat your lunch. Who drives this innovation? Our customers. There are 14 leadership principles at Amazon. One towers above all the others. Customer obsession. You can read this for yourself, but at some point I want to read it out loud and give you a few seconds to think about it. Leaders start with a customer and work backwards. They work vigorously to earn and keep customer trust. Although leaders pay attention to competitors, they obsess over customers. If you are involved in CAD and PLM at your organizations, I cannot stress enough that you have 2 sets of customers, internal and external. Too often we focus on only the external customers. And we have 2 sets of internal customers, our end users the people who drive Creo, Parametric, and Windchill, and the consumers of our deliverables, manufacturing, procurement, inventory, planning, marketing, sales, the entire enterprise. Are we earning and keeping the trust of our internal customers every day? So first, let's talk about how CADmins needs to change. And here's a question for the CAD or PLM administrators watching this webcast. Have you created and released a model or drawing in the past 5 years? And I mean a model or drawing for something that your company actually makes. Or how about the past 3 years? Or the past 12 months? We CAD administrators have to eat our own dog food. And that phrase comes from Microsoft. One Microsoft manager challenged another that they needed to use their own products internally. It makes sense. If you believe in your own products, why not use them? CAD administrators need to do the same. How much can our end users trust us if we're not an end user like them? CAD administrators need to have skin in the game. When I was at Lab 126, I was strictly CAD support, and I would tell all the end users the rules about how they should be modeling. Never do this, always do that. When I transferred to Amazon Prime Air, I went back to being a true end user for the first time in years. I was a vehicle designer doing cabling and assembly modeling. Creo and Windchill administration, those were my side gigs. Being an end user quickly changed my perspective. All the rules that I used to espouse sometimes took a backseat to schedule. There's a quote that's popular at Facebook that says, "Done is better than perfect." Many of the rules I used to tell people they had to follow really were for the benefit of Creo and Windchill, and not necessarily for the benefit of the end user, the product, or our external customers. When I joined Lab 126, the mechanical design on the Amazon Echo was pretty much done. I remember looking at the prototypes, not knowing what it really did because Amazon is an incredibly secretive place, and thinking, it looks like a cylinder. It looks like a cylindrical speaker. As part of my duties, I had to support and review the CAD modeling. And the CAD was good. It was really good. But was it perfect in terms of what we CADmins typically say is proper CAD modeling? The more important question in my mind is, does the CAD have to be perfect? More importantly, were our customers satisfied? One of the greatest aspects of the Echo is that our customers didn't even know that they wanted it until it debuted. It created a new market. Now, getting back to CAD, by no means do I advocate sloppy CAD modeling or PLM practices. My point is that being an end user quickly changes your perspective. If you're a CADmin and you want to get a better understanding of the challenges facing your end users, your internal customers, I recommend that you devote 10% of your time, which amounts to one morning or one afternoon a week, to program design work where you have to create deliverables on a schedule with milestones. Real CAD modeling where you are creating parts, assemblies, and drawings that you have to release using your company's processes. Next area where CADmins need to change, letting process become a proxy. Every year, Jeff Bezos writes a letter to the Amazon shareholders. He spends an incredible amount of time on it himself, and it goes through multiple drafts and revisions. They're not long, sometimes a couple pages, but they are brilliant and well worth your time. I recommend his 2017 letter especially. Jeff talks about not letting process become a proxy. What does he mean by that? Let's say that someone does something wrong in the engineering design world. You release components to manufacturing that have unwanted interference, you call out a wrong specification on a drawing, or you send the wrong revision of a drawing to a supplier. What's the usual response? Let's implement a process to prevent that from ever happening again. Let's add more rules to model check. Let's put more gatekeepers and workflows into Windchill. Let's add more reviewers and checklists and sign-offs. And let's add more steps, often manual steps, that our end users have to follow. The process becomes the proxy. 99% suffers because of the 1% edge case. Let me read part of Jeff's statement here. Good process serves you so that you can serve customers. But if you're not watchful, the process can become the thing. The process becomes the proxy for the result you want. You stop looking at outcomes and just make sure you're doing the process right. We've all experienced this at some point in our lives. You're dealing with customer services and their rules and processes prevent you or them from doing something simple or something that makes sense. When you implement or maintain processes that your end users, your internal customers hate, how does that demonstrate customer obsession? I'm not telling you to get rid of processes just because your end users hate them. I'm saying there's got to be a better way. If you have to add another process, automate it and put it in the background. Otherwise, end users will find ways around processes that are too painful to follow. And it's our job to take away those pains. Next, let's talk about how training needs to change. And as you're listening to this webcast, how many of you are looking at your phones right now? It's okay if you are, because that's the world that we live in today. And yes, this is an Amazon Fire phone. I help support it. And I'm one of the 43 people who actually bought one. Now, here's the dangerous part of my presentation. How long does it take you to reach your phone and unlock it? 10 seconds, 5 seconds, maybe 3? That's what you're competing against for people's attention today. The old model for training, where you're sitting in a classroom for days, the students watch a lecture, the instructor gives a demonstration, and then the students perform exercises, that doesn't work anymore. And irony alert, I'm going to criticize PowerPoint as I'm delivering a PowerPoint presentation. Jeff Bezos banned PowerPoint in executive meetings at Amazon in favor of a well-structured 6-page narrative. I found that people at Amazon and Blue Origin hate PowerPoint in training and demonstrations. People have changed. Our training model needs to change along with it. Of course, you can't replace training slides with well-structured 6-page narratives. But what do you replace it with? Jim Heppelman posted on Twitter about changing from just-in-case training to just-in-time. But I've seen, at least in the Jeff Bezos world, that it needs to change even further. It has to become on-demand and just enough. So first off, what's the biggest search engine in the world? Probably everyone here is guessing the correct answer, Google. Now think about this. What's the second biggest search engine in the world? YouTube. So how many of you have some kind of ticket system for end users to file help requests? Guess what? That's not where users go for help first. More and more I hear end users say when they have problems, they're going to YouTube. At home, I had trouble changing a shower head. Where did I go? YouTube. Many people use YouTube for home repairs, car repairs, and fitness and nutrition. If you have ticket systems for your end users to get help, you need to be performing analytics, making video solutions, and posting them. And keep those videos short. Average view duration tends to be around 3 minutes. And recently, I performed an analysis of 2,500 tickets at my company, and I found that less than 10% were issues where users were trying to figure out how to do something in Creo, Parametric, and Windchill. Now, it doesn't mean that we have all super users at our company. It just means that they're going somewhere else first rather than coming to our ticket system. The point of this discussion on the past couple slides was not about YouTube. It's about embracing external trends. That's what I want you to take away from the last couple slides. Once again, Jeff talked about this in his 2017 letter to shareholders. Jeff wants his company to stay what he calls a day one company, one that is full of vitality and nimble like a startup. Here's how Jeff describes day two. Day two is stasis, followed by irrelevance, followed by excruciating, painful decline, followed by death. And that's why it is always day one. Embrace those training methods that your end users embrace. Listen to your end users. Pay attention to those emerging external trends. As Jeff says, if you fight them, you're probably fighting the future. Embrace them and you have a tailwind. In the second paragraph here, Jeff talks about an obvious external trend right now: machine learning and artificial intelligence. Hold on to that thought. I'll come back to it in a few minutes. Third, computer-aided design needs to become computer-aided engineering. This means eliminating the silos between designers, analysts, and manufacturing engineers. Product development can't be a linear process progressing from design to analysis to manufacturing. It's too slow. Designers need to perform some of their own analysis and manufacturing. So how do you perform designers and engineers to perform simulation and analysis as part of their design work? I recommend starting with modal analyses. It only takes a few minutes to teach designers how to perform modal analysis. I know because I've done this. For example, one time on Amazon Prime Air, we had to mount a component on a mast away from the rest of the electronics. The engineer developed a few design concepts and options. How did he choose which way to go? I showed him how to perform modal analyses in Creo Simulate, and he had his answer. Those quick, simple analyses told him which concept was stiffest and assured him that its natural frequencies weren't near the RPMs of our motors and blades. The modal analysis also provided quick feedback on how to strengthen and lighten the part. In this way, empowering designers with analysis tools allows them to perform trade studies on their design concepts and select the best one, and then make it better. Once someone becomes comfortable with modal, you can quickly and easily progress to linear static analysis. You teach the designer the right way to apply loads and constraints, how to simplify design models, and they're on their way. Static analysis will allow them to size their parts properly, figuring out wall thicknesses, hole and shaft diameters, and where they need fillets. If you try to empower designers to do their own simulation and analysis, where will you get the most resistance? Not from the designers. Generally, I found that designers love doing their own analysis and not having to wait for the expert, who usually has a backlog of work they need to get to anyway. You get the most resistance and objections from the full-time analysts. They're used to performing finite element analysis, FEA, in ANSYS, Abacus, and Nastran with traditional H-type elements. They tend not to trust the P-type elements in geometric element analysis, GEA, in Creo Simulate. And they absolutely hate not having access to the mesh in Creo Simulation Live. I suspect there are other reasons, some valid, some not so valid, why they don't want engineers doing analysis. But if you want to get to market faster, design and analysis can't be isolated from one another. You still need analysts. You will always need analysts. You need their expertise to perform the full-blown studies prior to releasing objects. But you can't wait for the design to be complete before finding out that the product won't survive its operating environment. Next method for transforming computer-aided design to computer-aided engineering: manufacturing. And if you're a manufacturing engineer on the manufacturing side of the house, I want you to think how often you get designs from engineering that can always be manufactured easily and at low cost. So how do we get designers to perform manufacturing engineering? Let's look at three different areas. First, traditional subtractive manufacturing like CNC machining. Teach them some basic expert machinist, Pro NC, and mold design. They don't have to do the full-blown manufacturing process, but spending a little bit of time on this will teach them how to avoid complicated fixtures, excessive setups, rounds on the wrong edges, non-standard hole design or hole diameters, excessive undercuts requiring sliders, and inadequate draft to release a part from a mold. Second, additive manufacturing. And if you're not designing with this, you need to start. The benefits are incredible. More complex geometry, lighter parts, fewer fasteners, and the capability to refurbish fielded hardware instead of scrapping it. Make sure your designers have access to 3D printers for prototyping. It'll pay for itself in time saved and costs associated with external prototype shops. With 3D printing, you can go from a CAD model to a physical prototype in a matter of hours. There's nothing like holding a piece of hardware in your hands to catch mistakes early. More importantly, if you want to realize any of those benefits I just listed, get some additive manufacturing tools so you can start designing with lattices, configuring tray assemblies, and sending your designs off to in-house or external printers. Also, get some design for manufacturing and costing tools. We initially investigated DFM tools for cost estimates of the parts we had machined by outside vendors. We didn't know if we were paying fair costs for our machining or if we were getting ripped off. And the numbers we got out of the software told us that we were paying way too much for our parts. Now we have data that we can use to negotiate with our suppliers. But from a CAD perspective, that wasn't the best part of the software. DFM tools like DFM Pro from HCL, which is what we're using, analyzes your model geometry and provides feedback to the designer on manufacturability. Even better, it provides recommendations to improve manufacturability and reduce costs. And it works on both parts and assemblies. It takes tolerances into account, and it supports multiple manufacturing processes, included but not limited to mill turn, casting, injection molding, sheet metal, welding, and even additive manufacturing. So what are the different kinds of checks that DFM tools can flag? It'll tell you whether you're using standard hole diameters and tolerances, if your fillets and rounds are on the correct edges with the correct radii. It'll calculate your edge to diameter ratios, and it'll flag pocket depths that will cause tool chatter, and a host of other checks. You can even create custom checks. Right now, we've deployed it to our manufacturing engineers, and I started demonstrating it to our designers. We're considering adding DFM Pro to our design review process. We have a configuration data management step that includes running model check, and we're considering adding a DFM check to our manufacturing review step. Encourage your engineers to run some DFM analyses on their models. Find out which features add the most cost to their parts. But maybe don't make it a requirement. Again, avoid process becoming the proxy. If you do make it a requirement, figure out how to automate it and put it in the background, which is what we're exploring. Third method for transforming CAD to CAE, topology optimization. These are the next big things that will transform mechanical engineering in the 2020s. Remember what Jeff said about embracing external trends, and the obvious ones right now being machine learning and artificial intelligence? Topology optimization and generative design are the application of machine learning and artificial intelligence to design and manufacturing. If you're not familiar with the distinction between the two, topology optimization will compute the best least geometry for an existing part to meet boundary and load conditions. It's tailor-made for additive manufacturing and available today in Creo Parametric 5.0. You can think of topology optimization as coming in at the tail end of the design process. Generative design comes in at the beginning. Generative design will rapidly create numerous potential designs for given requirements. It creates more concepts faster than a person or a group of people could. It will create potential solutions, sometimes funky solutions, that you might never have considered. Now, I'm an old dog trying to learn new tricks. Having been educated and worked extensively in traditional subtractive manufacturing, my designs lean towards the prismatic and not the organic. This is where I see that I can benefit from topology optimization and generative design. The software can find the organic solutions for me that I can't. Generative design is planned for Creo Parametric 7.0, and we're looking to be early adopters. In the world of consumer electronics, drones, and rockets, you can never move fast enough, no pun intended. And given the competition, I'll look at any tool that can provide an advantage. Another Silicon Valley saying is that second place is the first loser. That, of course, isn't always true. Otherwise, we'd still be on Friendster or MySpace. But whoever creates the new market has a distinctive competitive advantage in that market. Generative design looks to be an enabler to product development organizations creating new markets. Finally, transforming CAD and PLM from support to strategic. In many product development organizations, CAD and PLM are seen as tools, and the CAD and PLM teams are seen in the same light as IT, part of the infrastructure. We need to be more like Patton here, the general on the battlefield, and less like support organizations. And by the way, I'm not mocking cooks. I used to be in the Army, and culinary specialists have the best career opportunities after their military service. And some of the best eggs I've ever had came from a field kitchen. CAD and PLM are your engineering and process definition. They are your company's products. As such, they should be taking a lead role in the enterprise. Now, how many of you work at companies that have their own software teams that write applications for internal processes? Those software teams won't like what I'm going to say next. We need to stop writing so many custom systems that do the same thing as commercially available packages. I'm talking about areas like PLM, MES, ERP, requirements management, and so on. Writing software for those areas doesn't represent the core competencies of our companies. Now, a little secret, don't tell anyone. A group I worked with in the Jeff world talked about writing their own CAD software. Let me say that again. They want to write their own CAD software, seriously, and they might still try to do it one day. Here's how it happens. There's a term in Silicon Valley called not invented here syndrome. It results from an overabundance of pride that makes you believe internally developed solutions are better. I remember trying in vain to convince a director that we needed to implement a solution for configuration management. If something ever happened, I knew a government regulatory agency would get involved. They'd want to know the as designed, as built, and as maintained configurations of our product. I suggested going with a major ERP solution. The company that provides that solution is almost as old as I am, has almost 100,000 employees, and configuration management is one of their core competencies. The director was a software guy who had never heard of PLM, MES, or ERP before I explained the terms to him. He had no previous training or experience in mechanical engineering or manufacturing. Again, he was a software guy. And when your only tool is a hammer, every problem looks like a nail. The director decided he would hire 5 software engineers, and they would write their own configuration management solution in 9 months. The idea was laughable on its face. It never happened. We have to get comfortable with the 85% solution. All systems today have APIs, application programming interfaces. Software teams can write plugins to those systems. They shouldn't be writing entire systems, especially not CAD, PLM, and ERP systems. And if we're turning down commercial software packages because they can't fit our specific processes and edge cases, then maybe the problem is with our processes. Maybe our process reinvents the wheel. Maybe we're holding on to a legacy system or process that's not made for the 21st century. I've seen companies get bogged down because this is how we do part numbering, and this is how we do change management, and this is how we do deviations, and so on. Part numbering systems, change management, and variances can often fall under the category of another Silicon Valley term, the anti-pattern, which is defined as a problem with a bad solution or a commonly reinvented bad solution to a problem. What do you do when you realize that the solution you've implemented is one of those anti-patterns? Jeff's 2016 letter to shareholders for the 2015 calendar year is a bit longer at 9 pages, but still well worth your time. He talks about the difference between one-way and two-way doors. Most decisions are reversible. Those are two-way doors. Those decisions can and should be made quickly with less than complete information. If your process is indeed holding you back, be willing to make a change. In the early days of Primaire, we had to invent our part numbering system. I told people it would probably take 3 or 4 tries until we got it right, and we shouldn't get attached to whatever we came up with. And indeed, our first system barely lasted a year, and that was okay. It was a two-way door, and when we admitted it wasn't working, we were able to come up with a better solution quickly. That was a high-velocity decision. The enemy of high-velocity decision-making is obviously slow decision-making, or even worse, no decision-making at all. We've all probably experienced a quote-unquote leader who goes out of their way to avoid making a decision at all costs. Learn to recognize these signs of actions that accidentally or purposefully slow down the decision-making process. First, the call for more data or analysis paralysis. As Jeff says, decisions that are two-way doors can and should be made with only about 70% of necessary data. Next, form a working group, which is the modern name for a committee. Third, gather stakeholder requirements. Next, perform a trade study. And when in doubt, wait it out. In other words, let something become overcome by events. Often these actions are legitimate and necessary, but there are times everyone knows a decision has to be made, either soon or right now. What's the solution in those cases? Some more words of wisdom from Jeff. When you aren't getting action or the right decisions, he believes in escalating the problem to higher levels, and escalating rapidly above multiple levels and all the way to him as necessary. Now, let's talk about how we transform from support to strategic roles. First, focus on the consumer. And this goes back to customer obsession. CAD and PLM tasks today tend to focus on the creator of data and not the consumer. On the CAD side, how much of our effort is based around 2D drawings? How much difficulty do your users have around getting views and annotations to look correct and making the right things visible? How much time do admins spend maintaining formats, templates, detail options, and all the other infrastructure around 2D drawings? Remember when I asked how fast you could pull out your phones? We carry in our pockets more computing power than Apollo 11, and we're always connected to the internet. Yet we're still relying on lines, squiggles, and words on dead trees to tell us how to manufacture and assemble our products. One time I took a trip overseas to visit our manufacturers. One of our contacts advised that if we could, we should keep our drawings to a single sheet, because if they're more than one sheet, they'll get separated and misplaced. We have to drag engineers who believe the drawing is the contract and manufacturers who can only work off paper into the 21st century. Other excuses for working off paper is that there might not be a computer terminal in the shop, or they might not have access to a shared project link site. Yet you go to some of the poorest neighborhoods in the countries of overseas suppliers, and everyone still carries a smartphone connected to the internet. On the PLM side, how much effort is spent on permissions, users not being able to check in or check out, design reviews, promoting and revising? How many Windchill implementations are used almost exclusively for PDM, product data management, instead of PLM? This focus on drawings in Creo Parametric and PDM in Windchill is creator-focused work. This needs to transform to consumer-focused work. What do I mean by that? On the CAD side, we need to move to a true technical data package, model-based definition. We have to get away from 2D drawings that get saved as a PDF and then printed out. A technical data package contains electronic information that can be leveraged by your downstream internal customers. A technical data package includes a 3D CAD model, either a native Creo Parametric file or an AP242 step file, with semantic or machine-readable 3D annotations that can be used by manufacturing. Inspection reports, including first article inspection and critical characteristics. Electronic parts lists that can be used by procurement and inventory. And drawing notes that can be updated automatically with changes to specifications. On the Windchill side, we need to embrace full product lifecycle management. This means moving beyond product data management to use the full breadth of Windchill. And this includes document management, change management, configuration management, BOM management, manufacturing process planning, and supplier management. Let's talk about these in a bit more detail. First, configuration management. This is capturing every component, cable, software code, and setting in your product from cradle to grave. Let's talk about a few of these different configurations. The as-designed configuration is your engineering bill of materials generated from your CAD assembly that creates the product structure in your WT parts. The as-planned configuration is your manufacturing bill of materials. The way that designers and engineers structure the engineering BOM usually doesn't reflect the way that your product is assembled and integrated, and that's okay. That's why we have EBOM and BOM transformation. As you're heading into a build for one of your products, sometimes you know that there are systems you plan for that aren't ready yet. For example, sometimes on Amazon Prime Air, we'd start building a drone before certain avionics or mechanisms were ready. If you're making a change to the as-planned configuration before you start building, that's a deviation. Sometimes during the build, you find that something gets built not to specification, but it should still be fine to operate. Changes to the as-planned configuration that happen during or after the build are captured in waivers. These deviations and waivers are known as variances, and the variances and engineering change requests that happen during a build result in the as-built configuration. And as you operate your product, you will perform maintenance, repair, and overhaul operations on it. Broken stuff will be fixed, worn out components will be refurbished or replaced, improvements will be made, and so on. The historical changes to the product are captured in the as-maintained configuration. Blue Origin achieved AS9100 certification this year, and it was hard. I'm the process owner for design and development, and I spent many days and hours in front of our auditors. They are thorough. If you ever think you might want to get industry certification like ISO 9001 or AS9100, you need to get your configuration management in order starting yesterday. Much of industry certification is about saying what you do and doing what you say. This involves documenting your processes and then creating and storing configuration items and records that show how you followed your process. You need complete traceability from requirements to design concepts through design reviews and manufacturing all the way to verification and validation. Windchill can help you in that area. You should commit to capturing as much project-related data there as you can instead of spreading it across multiple disconnected systems. Regarding BOM management, too often companies manage only one bill of materials, and that's the manufacturing BOM or MBOM. I've seen companies organize the CAD assemblies for their products in Creo Parametric to match the MBOM or the work breakdown schedule, structure. I remember on one project explaining EBOM, MBOM transformation to the head of supply chain, and his response was, no, there's only one BOM, the MBOM. Prior to releasing our CAD to manufacturing, he wanted us to restructure our CAD models to match the MBOM. He didn't understand how that's not always possible, and frankly, how it's ridiculous. On the same project, I remember trying to explain why we needed purchasing BOMs or PBOMs, as well as finance BOMs to know the true cost of our product. People didn't understand how these variants were derived from the engineering BOM or EBOM. Our planners thought that what you manufacture, that's the MBOM, and what you buy, that's the purchasing BOM, and when you add the MBOM to the PBOM, then you get the EBOM. Let's face it, people outside of BOM management don't understand BOM management. But the BOMs are some of the most important deliverables from engineering because they can affect the entire enterprise, especially manufacturing, supply chain, planning, and operations. I've seen a lot of manufacturing process planning take place outside of NPM Link. I've seen it managed with Word documents, Excel spreadsheets, and clipboards. I've seen work instructions generated by taking pictures throughout the first build and pasting them into PowerPoint presentations. Why perform manufacturing process planning through Windchill? Quite simply because it's linked to your CAD and engineering data. Associativity. You want to be able to update and sync changes to your process plans with changes to your product definition. And we're seeing the next step in the evolution of manufacturing process planning in the form of augmented reality. The short answer is, if you're already on Creo Parametric and Windchill PDM Link, and you're not using MPM Link for manufacturing process planning, you're significantly less efficient than you could be. For supplier management, I love McMaster-Carr. If you need something, their website is so easy to drill down to what you need, and they have CAD files in multiple formats for almost anything. For the same reasons, I love DigiKey, Amphenol, and Tyco Electronics for electronic components. For the same reasons I love McMaster-Carr and DigiKey, I hate McMaster-Carr and DigiKey. They make it too easy to put a specific commercial off-the-shelf component or COTS component into an assembly. Then when the bomb gets to supply chain, they don't know that you really need a number 10 socket head cap screw. They think instead that you need a McMaster-Carr 92562A239. This is where supplier management comes in. You can eliminate inefficiencies in the supply chain because an engineer called out a specific model from a specific manufacturer. You can help engineers call out the correct component and then identify the various manufacturers and vendors which can source it. So these are just a few areas where we can transition from Windchill from a PDM system to a true PLM system. So what does that get you? A few months ago, Jeff brought in Dr. Michael Greaves, the man who coined the term digital twin, to come in to speak to us. For us PLM geeks, he is the author of the seminal book, Product Lifecycle Management. Going back to his original definition of PLM, I'd like to read a sentence that I find critical. By trading information for wasted time, energy, and material across the entire organization and into the supply chain, PLM drives the next generation of lean thinking. Wasted time, energy, and material. Of those three resources, which one is the most critical? Time. Time matters in business. I mentioned the saying that second place is the first loser. Everyone wants to get to market faster. But let's take a look at the bigger picture. We only have so much time to accomplish something, to make an impact, to make a difference. At the bottom of the Blue Origin coat of arms is an hourglass with wings, specifically meant to remind us that time is fleeting. Let's maximize what we can do with the time we have and not waste any. In summary, there are 4 essential tools to keep your product development organization in a day one mindset. 1, customer obsession. 2, avoiding proxies. 3, embracing external trends. And 4, high velocity decision making. If you're going to create innovative products and new markets, the way you implement CAD and PLM to keep you in that day one mentality is by CADmins need to eat our own dog food by becoming end users and not letting process become a proxy. This is part of customer obsession. Training needs to become on demand and just enough. We have to embrace emerging external trends. CAD needs to transform into CAE by empowering designers with analysis and manufacturing tools. This enables high velocity decision making. And CAD needs to transform from support to strategic by shifting focus from the creators to the consumers and implementing true PLM across the enterprise. This represents all 4 tools to stay day one: customer obsession, avoiding proxies, embracing emerging trends, and high velocity decision makings. So where do we go now? If you're a CADmin, commit to 10% allocation to project work with deliverables. Second, read the Jeff Bezos letters to shareholders from 2016 and 2017 for the 2015 and 2016 calendar years. I've compiled all his letters in the Dropbox on my website if you want to download them. And there is a handout available for this presentation, which you can also download from the Dropbox. Thank you for listening, and now we will switch over to questions and answers.
Great, David. Thank you. This is Ron again. An excellent presentation. A lot of content. We do have a few minutes for questions. If you want to type them in, there's a Q&A box because all of you are on listen only mode. You fared, type them in. I did receive a couple of questions in advance here. So David, have you thought about how to apply just in time, just enough training with Creo and Windchill specifically? Because that's, a lot of your experiences with those two.
And thank you for the question. And the answer goes back to what I found YouTube. Again, I find that when users have questions or issues in Creo, Parametric, or Windchill, a lot of times the first place that they're going to is Google, and they're going to the video search results and getting answers. And so what I've done is when I have people come up to me or where they mention that they learned how to do something from YouTube, or they're asking questions about how to do something, I make a note of, hey, how can we take that and turn that into a video that people can access? Because one other thing that I found is that the best use of a support person's time isn't always helping one individual. And it's not always teaching a class to a group of 8 to 10 engineers. It's creating a resource that engineers and designers can get to 24/7 and get just the amount of information that they need that will unblock them.
That's great. Great. Thank you. And for those of you, as I mentioned, we will post the presentations and the recording, and in that David provided the links to his YouTube channel and also his books that he published. So you'll be able to access those if you didn't jot them down before. Another question is, there's certainly a generational difference in that when CAD, 3D CAD came along, most of the user base was either 2D drafting and maybe some 2D CAD. Now we have a new generation of younger people coming on that have some sort of 3D experience, think in 3D. So David, is there different approaches that you take for different people based on the culture that they come from?
The answer to that is absolutely. The way that you train someone like me is going to be different than someone who's more mid-career or entry level. And so a lot of it is paying attention to the users. And what I found is that the younger that the user is, the more that they hate 2D drawings. And so that's one of the reasons why we're shifting more towards that model-based definition approach, not only because it's more efficient, but just everyone tends to hate drawings. And I know that is sort of blasphemy for older engineers. When I bring up the subject with older engineers, they think that I'm just nuts and it'll never happen, but it's the way of the future. And you definitely have to tailor your approaches to support and training based on the age group that you're doing, because how you train someone in their 50s will be different than someone in their 40s and 30s and 20s.
Excellent. Excellent. Well, good. Any other questions from anyone in the audience? We're just coming up on the hour. Perfect timing. I don't see anything. So if you have any other questions, by all means, reach out to myself or David. He's pretty easy to find. He's got a lot out there, but if you have trouble, just reach out to me, ronw@ptcuser.org, and we'll get those answered. I have a feeling we'll be seeing you, David, again. You have some other good content. It was tough to kind of pick what we would do first. Thank you again from PTC User, the board of directors, as well as the membership, for sharing this information and spending the time with us. So I wish everyone have a good day, and we'll see you at the next webinar. Thank you.